To start off today, actually go back to the previous page that said dividing radicals. I want to go over one of the problems with you that I didn't go over yesterday. So if you did it and turned it in, that's fine, but you may need to do some correcting or at least just pay attention to how we solve this. Whoops. Okay, I want to be able to see the whole problem there. Okay, so we're doing number 8. Excuse me. Okay, so we had said in yesterday that we need to simplify radicals. Okay, so I'm going to simplify square root of 108. Well, it's even, so 2 goes into it 54 times. 54 is even. Okay, 2 times 27 is 54. 7 is not prime, or I'm sorry, 27 is not prime, but 3 goes into it 9 times. And 9 is not prime. 3 times 3 is 9. And now I have all primes that multiply to 108. Circle pairs. Here's a pair and here's a pair. And then this 3 doesn't have a buddy, so he doesn't have a pair. Okay. So when I simplify this in the numerator, I still have the 7 out front. I circled a 2, so a 2 comes out. I circled a 3, 3 comes out. And I had a 3 that didn't have a buddy, so he stays inside the square root. Now in the bottom, the problem we're going to have here is I have square root of 6. Okay? And I had said we don't want to have the square root in the denominator. That's what today is actually all about. Now there was a way we could have taken care of this when we did our primes over here. If I have a square root of 6 and I want to get rid of it, if I save a square root of 6, I'm going to circle in a different color here. I want a square root of 6. This right here would make it 6, right? 2 times 3. And then I still have a pair of 3s there. But then it leaves this 2 up here now as a lone 2. I know that looks a lot different than what we've done before, but this shows inside. I'm going to have all of this inside my radical. So let's rewrite. So kind of ignore what I did here. We still have the 7 out front. I wanted that. Or I circled this 3 down here at the bottom, so I have a 3, so times 3. I grouped that 2 and 3 together to stay inside the radical, so I have a square root of 6. And I had a square root of 2. And I'm leaving those separate for a reason, because when I have that square root of 6 on the bottom, these cancel out. Okay, so that would leave me with 7 times 3 is 21. And I have a square root of 2. Okay, so that was a little different than all the rest of the problems you had. You may have ended up, excuse me, with going ahead and multiplying this and then leaving everything else the same. However your answer looked yesterday, it's fine. But I wanted to show you one way to get rid of square root in the denominator on a problem like that. But today we're going to go over a totally different way to get rid of that radical in the denominator. So it's called rationalizing the denominator. Okay, we do not want square roots in our denominator. So to be fully simplified means there is no radical left in the denominator. Sometimes this can occur with dividing. The process of eliminating a radical is called rationalizing the denominator. To rationalize a denominator, multiply, whoops, if I can write, both the numerator and the denominator by the radical in the denominator, and then simplify. Okay? So I'm going to go ahead and do, let's see, I'll do one of the pretty easy ones for you, but I'm going to save 13 and 14 for you because they're quite a bit easier. Actually, I'm even going to save 15 for you. So come down here and let's do 16. I don't want to do all the easy ones. I want to save you some. Okay? Remember, this is square root of 6 over 18, which we can split up into square root of 6 over square root of 18. Okay? We could simplify things here, but we're not going to. What I'm going to do is just do the rationalizing of the denominator. So in the denominator, I have a square root of 18. So to get rid of it, I'm going to multiply both the numerator by square root of 18 and the denominator by square root of 18. Because that's multiplying the entire fraction by 1. Square root of 18 over square root of 18 is just 1. We can multiply anything by 1 because it doesn't change what we have. Okay? So, and we do this because square root of 18 times square root of 18 just gets rid of the square root and leaves you with 18, okay? Because it makes it a perfect square inside the root if you were multiplying 18 and 18. So now we just don't have that radical. But then we have to take 6, we have square root of 6 times square root of 18, which is square root of 108. Okay, we do need to simplify. So over here, I'm going to have square root of 108. Let's see, it's even, so 2 goes into it. 2 times 54. 54 is even. That's 2 times 27. Okay, 27 is not even, but 3 goes into it. 3 times 9. And then 9 is 3 times 3. So now I'm down to all prime numbers. Circle pairs. Okay, then we have this lone 3 there that's going to stay outside. So if I rewrite this radical, square root of 108 has a 2 on the outside, a 3 on the outside, so I'm going to multiply those together. Square root of 3 over 18. So that makes 6 square root of 3 over 18. And we're just not quite done. Okay, we did rationalize the denominator, so what we have written is true. But we want to simplify. 6 and 18 can simplify, okay? Well, 6 goes into both of those. So if I'm going to take a 6 out, that leaves me with a 1 here and a 3 here, but we don't need to write 1. So on top I have a square root of 3. Well, it's 1 times square root of 3, but we don't need to write the 1 in front. And on the bottom I have 3. So here is my simplified radical after rationalizing the denominator. Okay, so let's see. Let me pick another one here. Let's do number 18. Let's just go straight down here to number 18. Okay, now in the denominator here, I have a 10, so I have a whole number and a radical. But I only have to get rid of the radical. I don't care about that whole number. I mean, well, I do, but I don't need to get it out of the denominator. So to get rid of the radical, you multiply both the numerator and the denominator by that radical. Okay, so I'm multiplying by square root of 3 over square root of 3. Okay, so in the numerator, I have square root of 4 times square root of 3. So 4 times 3 is 12, so I have square root of 12 over, I still have the 10 in the denominator, and then square root of 3 times square root of 3 is just 3, because it made square root of 9, which is 3, okay? That's what you're doing when you're multiplying both the numerator and the denominator by that radical from the denominator. You're making a perfect square inside the radical, so that way, in the denominator, so that way it can come out to a whole number. All right, let's simplify some things here. Well, I need to simplify square root of 12, so let's do that over here. Okay, 2 times 6 is 12. 2 times 3 is, oops, that didn't write a good 3. Let's undo that. Okay, here's a pair. Then we have this lone little 3 there. Okay, so if I rewrite this, square root of 12 is 2 square root of 3. In the denominator, I had 10 times 3, which is 30. Okay, so we rationalized the denominator. I even simplified the radical on the top, but my actual fraction still simplifies some more. So this is a correct answer, but we want it as simplified as possible. So 2 goes into both 2 and 30. So 2 divided by 2 is 1. 30 divided by 2 is 15. So in the numerator, I have 1 times square root of 3 now. So we just write square root of 3. the denominator, I now have 15. So there would be my answer. Okay, let's find another one. Let's go over to 19 here. Trying to pick some of the ones that I think will be a little more complicated. All right, so we have a square root of the 10. We have a square root of 10 in the denominator. Now, I could simplify my radical in the numerator, but I'm going to have to simplify later, so I'm just saving it till then. So we need to get rid of the denominator having a square root of 10, so I'm going to multiply the denominator and the numerator by that radical, so by square root of 10. Because that's just like multiplying by 1, and you can multiply anything by 1. Doesn't change what you have, even though it changes the look of what you have the way we're doing it. Okay? So this becomes 5 square root, and 12 times 10 is 120. Oh, it's not writing. There it goes. And then square root of 10 times square root of 10 is square root of 100, which is just 10. Okay, so we do need to simplify that 120, square root of 120. So I'm going to come over here to the side. Okay, it's even, so 2 goes into it 60 times. 60 is even, is 2 times 30. 30 is 2 times 15, and 15 is 3 times 5. So there's all the prime numbers that multiply together to 120, 2, 2, 2, 3, and 5. Circle any pairs. Here's a pair of 2s. Then all of this doesn't have actual pairs, so it's actually staying inside the radical. Just remember, we're going to multiply them back together. Okay, so square root of 120 is what I simplified, so if I rewrite what I have, I still had a 5 in front of that square root of 120. I circled a pair of 2, so a 2 is coming out, so 5 times 2. Inside the square root, I have 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So I still have a square root of 30. And in my denominator, I had a 10. Excuse me. Well, 2 times 5 is 10, square root of 30 over 10. And these 10s, 10 over 10 is 1, so they go away here, and I'm just left with square root of 30. And we know it doesn't simplify because I made it from prime numbers that don't have pairs. Okay, let's do number 23. Let's come down to 23. All right. Now, square root of 8 what would simplify, but I'm going to just simplify at the end. So get rid of that radical. I leave that 2 is going to stay there. It's a whole number. I don't need to multiply by it. I just multiply by the radical of 8 over the radical of 8. Okay. So inside the radical in the numerator, I have a 3 times 8, and that's 24. The denominator now, I have that 2 out front. Square root of 8 times square root of 8 made 8. No more square root. All right, so I'm going to simplify some things. I know in my denominator, if I can write, there we go. I'm going to have 2 times 8, which is 16. But in the numerator, let's simplify that square root of 24. Okay, so that's 2 times 12. 12 is 2 times 6. 6 is 2 times 3. Okay, so all those prime numbers. Here's a pair of 2s. These guys don't have pairs, so I'm going to actually multiply them back together and put them back in the square root. So outside of the root, I have a 2. It's not letting me write. How come? There it goes. Inside the root, I have a 2 times 3, which is square root of 6. Okay, this 2 and 16 simplify. 2 goes into both of them. 2 divided by 2 is 1. 16 divided by 2 is 8. All right, so in the numerator, I have 1 times square root of 6, which is just square root of 6. In the denominator, I have 8. Okay. Yeah, I'm going to save 24 for you. So, let's see. Whoops, let me zoom out here. So, I want you, no, I'm going to go ahead and do 24. Haha. You're welcome. Okay. So, let's get rid of that 12 in the denominator, that square root of 12 in the denominator. We've got to rationalize it. So, I'm going to multiply by square root of 12 over square root of 12. All right. So, my numerator becomes, it has a 4 out front, and then I have square root of 5 times square root of 12, which 5 times 12 is 60. So I have square root of 60. And then in the denominator, square root of 12 times square root of 12 is 100, square root of 144, which is 12. All right, let's simplify that square root of 60. Well, that is 2 times 30. 30 is 2 times 15. And 15 is 3 times 5. So now I have all the prime numbers, 2, 2, 3, and 5. Here's a pair of 2's. This 3 and 5 aren't pairs, so I'm actually going to multiply them back together and put them in the root. So let's rewrite our problem here. So I still had a 4 outside of the radical, okay, right here. But square root of 60 turned into a 2 on the outside because I had a pair, so it's times 2. Inside my radical, I have 3 times 5, which is 15. And in the denominator, I had a 12. Okay, let's simplify. 4 times 2 is 8, square root of 15 over 12. And I can simplify that 8 and 12. So you find a number that goes into both of them. Well, 4 goes into both of those. So 8 divided by 4 is 2. 12 divided by 4 is 3. So this became 2 square root of 15 over 3. Okay, so your job today, whoops, if I can zoom out here without writing all over everything, is to do 13, 14, 15, 17, 20, 21, and 22. So that's 7 problems. You can have it checked, but that is what you're doing, okay?